Okay, so today we're talking about quadratic functions, but first, some quick, hopefully, review for you guys. If not, this may be some new material. All right, so we've talked about different types of functions.
You're not presenting.
I'm sorry?
You're not presenting.
Oh, that would help, huh? Thank you.
Now you are.
All right, thank you. So the most basic function that you learn in algebra is a linear function. Okay, we call this one in particular binomial because there's two terms, right? You have your linear term, the ax, and then you have your constant term, the b. We also have what's called a constant function. Okay. This would be a monomial, mon meaning one, okay? And this would just be a number. So if you graphed it, it would just be a straight horizontal line at whatever value this is, right? If it's 2, it goes across the 2 on the y-axis. So we talked about certain graphs and their shapes. Okay, so the basic parent function is the squaring function. Okay, and when we went over this, like I said, the shapes of different graphs, we talked about this, right? This gives us a parabola. Parabola. Right, but this, like the constant, is just a monomial. This is only going to give us one graph. We can manipulate this term to give us, a different form of graphs, and actually, we can use the squaring function to model a lot of real life examples. Okay, real life phenomena and things like that. Okay, so quick question: what science are you guys in? Are you guys taking a science class this year?
Physics.
Some biology, some physics?
Mm-hmm.
Okay, so you'll definitely see this in physics, okay, with projectile motion. And next year when you guys do calculus, that's a big topic. Okay, so first let me give you so once we get above binomials, we could start calling them, trinomials and stuff like that. That's too much. So we just kind of call everything above a binomial polynomials. Poly being the prefix there, meaning many. So you have many terms. So this is a fancy way of saying it. And I'm writing it like this to get you familiar with a few different ways things in math are written. And I ran out of room. Okay. So when we originally had maybe last year when you saw your quadratic function, you saw ax squared plus bx plus c. When we deal with linear functions, you either see mx plus b or here like this, ax plus b. Now with polynomials, we don't know how many terms we have, so we can't really use different letters, right? If I had a, b, c, d, if I had more than 26 terms, I'd run out of alpha, I'd run through A through Z, and then I'd be out of luck. So what we use are subscripts, right? So I'm just using A for my coefficient, right? So remember the coefficient is the number that goes in front of your variable. So here, these are all different numbers, okay? an minus 1, an minus 2, a2, a1, right? And at the end there, I don't think that's a0. I'll make that a little nicer. Okay, you might hear me refer to it or anything with a sub-zero as a naught.
What is that little thing that you wrote by is x n minus 2 plus and then there's something there. What is that?
Just dot dot dot. Like it continues. You can have because I don't know where I'm beginning here, so it's just like fill in the blank. So it's not you don't need it. It just shows that there's a bunch of stuff that's in between that I'm not showing because it would be too long to write out everything.
No, I thought you meant something like e is not equal to 4.
Oh no. We're not dealing with any of that yet. No. But good question. Okay, so a few things that we need to know. Okay, so this we would call a polynomial function of x. So that just means the variable that we're using is x, right? And that's what this means when we have this. Not on. Let me see, yeah. With degree n. Now, when I say degree, did you guys go over that last year? The degree of a polynomial?
I want to say yeah, but I don't remember.
Okay, so the degree is the highest exponent that you see, the largest exponent you see. Okay, so if you had, if you had x to the fourth plus 3x squared, it would have a degree of 4 because the 4 is the highest exponent. Okay, so that's pretty straightforward. So whatever the largest power is, that is the degree of the polynomial. So it doesn't matter, it could just be the x4 by itself. It could be an x4 followed by, x to the third, x to the squared, x, and a constant. You're just looking at the largest exponent there. Okay, so we're going to be talking about degrees of all types, okay, and their different properties. We'll get into all that. But for today and probably tomorrow, we're just going to be focused on our quadratic function. Okay, so I'm going to start throwing some mathematical things at you. This here is a mathematical symbol. It's like an E, but it's kind of like you do a C and then you draw a line through it, okay? And it means contained. So here, I'll write this out for now. I'll, explain what this means. It's translation. But if you see this, just know that this is saying that A, B, and C are real numbers, okay? Officially, this means A, B, and C are contained in the set of real numbers, but this just means A, B, and C are real numbers, okay? So if you see this in the future, just know that it means kind of, it's in that, it's within that range. Okay, so for now, we're going to be looking at our quadratic function as ax squared plus bx plus c. Okay, there are different forms of quadratic functions. We probably won't see them until tomorrow. But this is this? Okay, so this is not, no, okay, so this is weird. All right. I usually call this standard form, but it may not always be referenced as standard form, so I don't want to say that right now. Okay, any questions so far? I mean, we haven't really gone over much, but just basic stuff. Okay, so again, A, B, and C have to be real numbers. They're not going to be imaginary numbers. They're not going to be complex. Okay. Our solutions, when we start solving these, our solutions might be imaginary numbers, but you can't have imaginary numbers as coefficients. Okay, it's no longer a function. All right. So without getting too much further into this, we talked about the graph. Okay, there's a few key components of graph of quadratics that can help us determine parts of the function, or again, we can go to different forms of our function that'll help us with the graph. Well, first, right, the general shape of a quadratic is a parabola. All right, so our parabola has a few different components. Hopefully these words will be pretty familiar. First, we have an axis of symmetry, okay, or sometimes just known as the axis. Okay, so on your graph, it goes through the middle of your parabola. And in terms of geometry, it doesn't look like it here because this is just a sketch, but the axis of symmetry serves as a reflection line. Okay, anything that happens on the right side has to be mirrored, has to be reflected over to the left side. Okay, so your parabola will always be symmetrical on the axis of symmetry. Okay, in geometry, you guys mostly talked about symmetrical over the y-axis or the x-axis. Okay, but we can move that symmetrical line on the graph. Okay, and our parabola follows that line. With respect to the axis, where it crosses the graph, we call that the vertex. Yeah, okay. Okay, is the point where the parabola intersects the axis. Now, there's something else special about our vertex. Okay, for a parabola, the vertex will either be the maximum value or the minimum value, depending on how our parabola looks, right? If I had a parabola like this, okay, our vertex would be the max because it would be the highest point. In this example, our vertex is the minimum value because it is at the bottom. There will be nothing lower than wherever this is. Okay. Okay, we got 7 minutes. What else do I want to talk about? Do you guys have any questions right now? Okay, can I flip this page? Are we good? All right. So looking at our leading coefficient, okay, the ax squared part, depending on what our a is, tells us, again, something else about our graph. If let me put it down here. If a is greater than 0, okay, if it is a positive number, now it could be a fraction, it could be a whole number, but again, if it's positive, okay, our parabola will open up, right? So you'll have your normal parabola. If your a is less than 0, okay, in terms of, geometry and things like that, when we throw a negative in front of a function or a term, it reflects it over the x-axis. So if your a is negative, if it's less than 0, your parabola will open down. And then a can tell us two other things. So if the absolute value of a is greater than 1, so if it's, 2, 3, 4, if it's a larger number than 1, okay, positive or negative, so it doesn't matter. Okay, we talked about this a little when we were going over the general form of graphs. This is going to stretch the graph vertically. Okay, so an example, here we have the basic, oh, that's ugly. Here, if I had our basic x squared, if I put, 3x squared, that would make it skinnier. Okay, it would stretch it up. Okay. So yeah, there's a few different ways we can say that. So like it stretches vertically or it makes it skinnier. I'm not sure, again, you may have learned a different way to kind of classify that in algebra. And then our last part. Okay, if a is a fraction, if the absolute value of a is in between 0 and 1, okay, we say that the graph shrinks vertically. So again, I'll give you our basic x squared, right? If that's what x squared would look like. If I had 1/2 x squared, okay, it would kind of flatten it out. And it would be a wider parabola. All right, any questions with the basic classifications and properties of parabolas and quadratic functions.
No.
Okay. All right. So